average starting salaries for Oracle database administrators? And did you know that in the United States, Oracle DBAs earn on average $100,000 a year? That's a pretty comfortable salary, and I hope it has you being really excited about being a student in this class and learning how to administer Oracle Database 12c. In this overview module, we're going to start with what are your goals as a student and what do you hope to get out of this course and learning path. We'll then get right into the meat and potatoes and discuss what exactly Oracle Database is, what is the difference between a database and an instance, what exactly is client-server architecture and how does Oracle fit into that schema, and we'll conclude this lesson with a review of the Oracle Database 12c memory structures. The memory structures and background processes form what's called the instance, but I get a little bit ahead of myself. I understand as your instructor that you come from a particular background. Perhaps you're new to databases and you've always felt an attraction to them somehow. Maybe you've used. The question of the day for you as my student is probably, what is Oracle Database 12c? And to answer that question, let me take one step back from that and let's treat the subject of what is a database. A database is simply an organized collection of data that's treated as a unit. There are many kinds of databases. Flat file is what you have in, say, Excel. Relational is what we have here with Oracle and Microsoft SQL Server and MySQL and many of those platforms. More recently, with the so-called big data movement, we have a movement toward NoSQL, as it's called. But here we're discussing Oracle, which is an example of a relational database management system, or RDBMS. RDBMS refers not to the database itself, but to the infrastructure that supports database access. So Oracle Database, the instance, consists, as we'll learn, of various in-memory structures, binary files that are laid down on the database server's file system, background processes, a lot of under-the-hood plumbing. The actual data is stored in the database, and in Oracle that refers to several file system objects, as we'll talk about later. A hallmark of any relational database is secure data storage. We want data to go into our tables correctly with integrity rules, and we want to be able to retrieve just the information we need and no more by using an access language such as the Structured Query Language, or SQL. Now, Oracle is officially called an object relational database because it contains all of the elements of the relational database and also includes many aspects of object-oriented programming, or OOP. OOP deals with things like creating your own custom data types that can be duplicated many times. They can inherit properties from each other. OOP is an entirely different subject. But just know for now that officially Oracle has the best of both worlds. Now, if you're wondering what exactly a relational database brings to the table, if you're interested in the history, you should look up E.F. Codd, or Ted Codd as he was called. He wrote a paper in 1970 called A Relational Model of Data for Large Shared Databanks, and that is like the seminal paper on describing what a relational database is. And basically, in the relational model, you have data stored into tables. The old-fashioned term that Codd used was relations. You might have a table that stores just employee information. The table consists of columns that, in the old-school Codd language, were referred to as attributes. These could be fields like EMP-ID, first name, last name, address, and then each record or row in the table, which in this example would correspond to different employees, is called a tuple in Codd language. But nowadays, in the 21st century, we talk about tables, columns, and rows, or records. What's especially cool about relational databases is that you have tables not containing redundant information, but instead using shared columns to create relationships between tables. You can then use SQL, our data access language, to pull data among multiple tables. I'll try to inject best practices for relational database data modeling as we proceed through the course, but remember, I'm cleaving very closely to our exam objectives chiefly. So now we know a little bit about what Oracle is. Where did Oracle come from? Well, in a nutshell, Oracle version 1 was written but never officially released by three guys named Larry Ellison, Bob Miner, and Ed Oates. They formed a company that eventually became Relational Software Inc., And given that Codd's paper was written just 8 years before, you can see that Oracle has been in the relational database business since the beginning, and it's certainly a market leader today in 2014. You'll notice trends more recently. You'll notice that we have 8i released in 1999, 10G released in 2003, and 12C, the version we're concerned with, released in 2014. Now, what are those one-letter identifiers? As you can see, the 8i release brought a lot of internet web capability to the table. You had the ability to interact using SQL from a web browser. That was a big deal in the late 90s for sure. In the early 2000s, with 10G, this is where Oracle brought grid computing to the forefront. Now, what is grid computing? In a nutshell, a grid infrastructure refers to deploying what's called a massively parallel infrastructure, where you have things like a storage fabric, where you have shared storage that consists of pluggable hard drives that you can just expand by adding. Understanding Oracle client-server architecture. Now, one common misconception that some newcomers have is they mistake the client for the user. A client in client-server architecture refers to the application. And yes, there's a user behind that application, dollars to donuts, but the client nowadays is going to be typically a web browser. A user is going to use that browser to communicate either at a middle tier level, so-called middleware, and then the application server is the one actually querying the database that exists on the back tier or the data tier. Oracle fits in on all of these levels in a multi-tier web application environment. It's pretty crazy. In the middle tier, you may have a homegrown line of business application that performs business logic for your users, but Oracle has an entire suite of middleware applications called Fusion applications that cover just about any use case a business could want. Human resources, enterprise resource planning or ERP, customer relation management, CRM. You got it. It's expensive. In fact, anything in the Oracle suite is expensive. That's for darn sure. But the neat thing, or one neat thing about staying with Oracle in your N-tier stack is that you have unified support. In other words, if you run into a problem anywhere in a tier, you have the same support team and all of your stuff is covered, all of your software is covered. Middle tier is almost always communicating with the front tier using HTTP or HTTPS. And actually you have the Oracle WebLogic web server to take care of the front end. Like I said, Oracle has all of these tiers covered. We're specializing in this training, of course, in the back end, this Oracle database, the storage tier. And we call it storage tier, but the back end Oracle can do more than just securely store data. We have PL or procedural SQL that gives you an imperative programming environment, an object-oriented imperative programming environment that you can mix and match in with SQL, which is your declarative data access language. And going even further yet, Oracle has teamed with various hardware vendors and created a combination appliance, hardware-software appliance. There's actually a number of these. But in general, if you do a search for Oracle Exadata database machine, it's just astounding computer power in a half rack or a full rack configuration. You get your storage, your back-end Oracle, all clustered up. You basically just plug it and go. It's pretty crazy. Now let's address another common entry point of confusion for those who are relatively new to Oracle. What's the difference between a database and an instance? With 12c actually, and you notice that down toward the bottom of the slide I highlight new features in red. I hope that'll help those of you who are currently Oracle experts get to what's important for you. But it's gotten a little bit more complicated, but traditionally a database and an instance are in a one-to-one relationship. In a single instance installation, you have your instance, which is the shared memory areas, like the system global area, the private memory areas, it's called the private global area or PGA, and then your background processes. We'll talk about the background processes in the next module that support the database proper. And in Oracle, as I said earlier, the database in Oracle refers to file system objects. Now, you could make the argument, aren't background processes file system objects? I mean, it's executable code. Yes, don't go there though. Okay, just follow me here. The database refers to files like your data files that are your binary objects that actually contain your row data and your indexes. your online redo log files, which again are binary files that store a record of DML and DDL changes to your database that are used in database recovery if something bad were to happen to your database. Your control files, which provide intelligence to the instance as to where all of these components are, and so on. Now, I said that the issue of database and instance gets a little bit more complex. What I mean by that is that up to Oracle 12c, you had either a single instance where if you wanted a database installed, you would install an instance and then you'd create a database that goes along with that instance. Question for you, do you think a single Oracle server can have more than one database on the same box? The answer to that question is yes. You can do that, but you'll have separate sets of background processes, separate SGAs, separate PGAs, and if you're thinking to yourself, wow, that's a lot of RAM and CPU and potentially disk space, you're absolutely correct on that. Now, the clustered instance, what's called the grid instance, remember that 11G is grid, but you can do grid just as much with 12C. This involves two or more nodes or database servers that have the Oracle binaries installed. They are instances, but the difference with a clustered environment, what's called RAC, Real Application Cluster, is that those nodes are focused on shared storage and a single database. What's even better is that you can set up your grid in an active-active configuration. Typically in a cluster, maybe a SQL Server cluster, you have active-passive, where one node is actively up, accessing the data files, and the other ones are just basically sitting there twiddling their proverbial thumbs. With Oracle RAC, we can have active-active, which is parallelization, because we can support more user access at once. And those nodes are always communicating with themselves so they won't step on each other's changes, you see. Data integrity is absolutely crucial in the relational model. Now, what's new and what's changed here? In Oracle Database 12c, we have a very, very fundamental shift toward a multi-tenant architecture. And what this is, it's one-to-many, but instead of it being many instances to one clustered database, with multi-tenant, it's just the opposite. You have one container database in one instance, and then you can have one or more pluggable databases or PDBs plugged into that container database. Isn't that cool? Each of the pluggable databases has its own private area, its own users, its own schema. As far as your applications and users are concerned, those pluggable databases might as well be in a single instance on a separate server. The idea with multi-tenancy is that you're consolidating or collapsing a whole bunch of what otherwise would be separate instances into a single instance. And that's great because it's going to reduce your cost of hardware and it's going to make it easier for you to manage multiple databases. This is especially important in a cloud environment. In a cloud environment, you may be offering database as a service, infrastructure as a service, or there are so many of those cloud buzzwords floating around. But in other words, you may have need to deploy several databases and you just don't have the hardware to put them all stacked in separate instances, you see. Finally, you can do updates, patching, that kind of stuff just once on the CDB instead of every time for every database. We'll be getting more and more. We'll be circling back on the multi-tenant architecture as we move through this course. For now, though, let's spend the rest of our time together looking at Oracle memory structures. Memory structures should lead you to think this is volatile. This is data that's stored in the server's random access memory, or RAM, and therefore is in jeopardy of being lost if, for instance, somebody trips over the power cord and the Oracle server just goes down unexpectedly. The two memory structures are the SGA, or System Global Area, and PGA, the Program Global Area. The System Global Area, or SGA, is defined as a group of shared memory structures that contain data and control information for a single database instance. Like I said, that gets a little complicated when we deal with pluggable databases, but for now let's constrain our discussion to the traditional single instance Oracle database. The Program Global Area, there's actually going to be many of these as you'll see in just a second, is a memory region that contains data and controls information for a server or background process. And here's a key difference. Access to the PGA is exclusive to the process. What is a process? Well, that's a good question actually. Let's proceed and I'll tell you. In the System Global Area we have various components. And actually I'm going to break out into the web browser again to show you something cool. If you would, pop open a web browser and use Bing or Google, whatever your favorite search engine is, to search for Oracle Database 12c Interactive Quick Reference. This is such a great interactive site. As you can see, it's divided into several categories, looking at different views. I want to draw your attention to database architecture. What this will do is show you this Mondo architecture diagram that is just very complicated when you first look at it. When you double left click, it gives you a zoom view where you can come in closer. Here we're looking at different caches in the system global area. If you double left click a cache, you can see on the right it gives you a little blurb to define what it is, and then check this out. You'll see a link that goes directly to that location in the Oracle documentation. Now, heads up, the Oracle documentation is outstanding. I've been in the IT industry for a number of years, and I've never seen any documentation as meticulously maintained and accurate as the documentation for Oracle Database. It's awesome. That having been said, throughout this training, I'll always be giving you references to books, media, websites that I think are helpful to you as a developing Oracle DBA. Please know that I'm not being paid to give you any references, and I'll never reference a book that I haven't actually read or a website or product that I don't actually use and visit. Let's briefly discuss the major components of the system global area. Like I said, this is a memory area that's all volatile information. So what is most important to me are things like the first two items here, the database buffer cache. This is a memory cache that stores copies of data blocks that have been read from data files and have not yet been written back to the data files. Maybe they don't need to be written, but just as likely they were. So you have various stages of the buffer cache. For instance, you might have a user who runs SQL to pull back a bunch of rows. Well, Oracle is going to fetch those rows from the data files on disk. Temporarily thereafter, those rows will be stored in the buffer cache, so if another user runs a query that references those rows, Oracle can satisfy the query by grabbing the data from the cache. Therefore, you get great input-output performance by using the buffer cache. The buffer cache also stores changes, so it's crucial that Oracle periodically flush the contents of the buffer cache, that is to say changed data blocks, back to the data files where they're recorded permanently. And we'll circle back on that in the next module. Another buffer that's extremely crucial is the redo log. This is a separate memory area that works in a circular fashion that stores all changes made to the database. So as users execute SQL to do DDL, that's data definition language, create, alter, drop, etc., DML, that refers to things like insert, update, delete, those changes are recorded in the redo log, first in the buffer, just in memory, and then when a checkpoint occurs, those changes, those SQL operations, are flushed to disk in your redo log. And hopefully you've got your Oracle database configured to archive your redo logs, so that in the event that you have to recover from a backup, you can bring your database to as close to the time of the failure as possible. Other pools, there's several that aren't quite as important in my humble opinion. The shared pool is sort of a catch-all bucket that Oracle uses. Shared SQL, the data dictionary or metadata cache is storing its stuff here temporarily. The large pool is what I consider an overflow area that stores memory that can't be fit in the shared pool. Remember that Oracle owns Java, so there's heavy reliance upon Java throughout Oracle products. The Java pool stores Java Virtual Machine and Java code in a temporary cached way. Remember, cache itself refers to a storage area, and the idea with cache is that we want fast I/O instead of having to go to disk. Streams, you're not going to use at all unless you're using Oracle Streams replication. Nowadays, Oracle has deprecated Oracle Streams and instead wants you to use one of their products called Golden Gate if you have need to have warm or hot standby replicas of your database. And then the fixed SGA is just an in-memory area that's used by Oracle for internal housekeeping. The program global area is per process. In other words, your users who connect to the database are going to be captured. Their session is going to be managed by a server process. Background processes are also captured in their own private workspace. And there's a cool analogy in the Oracle documentation for understanding the relationship between the server process and the PGA. The way the analogy works is, imagine a temporary countertop workspace used by a file clerk. So the file clerk would be the Oracle server process, and the server process does work on behalf of the customer. The customer in this case would be the client process, the user connected into the database. So the clerk would clear out a section of the countertop and use the workspace to store the customer's data. If the customer, for instance, were going to ship a package, you'd have the package, you'd have their paperwork, you'd have their payment. All that stuff is per user, and each user would have their own clerk working with them and have their own private bit of countertop to work with. That's really what we're dealing with the program global area. The PGA stores session memory, users' logon information, their preferences, and then as the user executes SQL, you have a work area in memory just for them. Now, if you're thinking this could occupy a lot of memory, you're absolutely right. Another new feature in 12c is that you can actually restrict the PGA size using an initialization parameter called PGA aggregate limit. And in the third module, we'll learn all about initialization parameters. So don't get too freaked out when I use some terms that may not yet be comfortable for you. I'm aware as your instructor of those kind of foibles, and I'll address them all as we go along. The subject of managing memory in Oracle database is a long historical argument. It used to be many years ago that the DBA was forced to set all of those memory cache values, the maximums, manually. It's terrible. Nowadays, though, fortunately, we have automatic memory management where you can set an initialization parameter and say, okay, Oracle, I'm going to give you free rein to manage memory through all of those different caches and the PGAs and the SGA. Do it yourself as you will, but don't go over this memory target. Oracle does give DBAs the ability to do manual memory management, and traditionally that's only extended to the SGA, but nowadays, as I said, if you want to, you can manage all aspects of the SGA and PGA caches yourself. Let me dip into the Oracle Enterprise Manager Express tool to show you just the basics of how that works. We'll learn more about the administration tools in the next module. For now, just know that Oracle Database 12c includes a lightweight web console called Enterprise Manager Database Express 12c. Let me log in here as the system built-in user. One thing to keep in mind, the 12c Enterprise Manager uses Adobe Flash technology, so you have to have the Adobe Flash plugin loaded in order to get this console displaying. And I'm leaving aside all political arguments with Adobe Flash. It actually makes for a much faster, prettier outlook, as you can see here. If you've used Enterprise Manager in 11G, it gave a lot of information, but in sort of a clunky way. The downside to Database Express 12c is that it doesn't have anywhere near the level of functionality that OEM or Oracle Enterprise Manager had in 11G. But like I said, we'll discuss that later. For now, to get into your memory management stuff, you'd go to Configuration, Memory, and that'll take you momentarily to a memory-related page where you can see different advisors and different graphs. If you're into data analytics, that's a cool thing. If you click Configure Memory, it's going to take you to a brief table where you can review your settings, your initialization parameters, as they relate to memory usage. Again, we're not getting quite the flexibility that we used to in previous versions of Enterprise Manager. We can use other tools to set those initialization parameters if we want to.